explain me briefly how were errors measured of this experimental dose?
Well, I determined the blue values of the light using my photograph, and I chose a rectangle in the center, or a square, and then I determined the mean value, and I also determined the median and the deviation from the. So I could.
And also on the slide number 13, there is a comparison between a theory and experiment.
Yeah.
Theoretical values are predicted, as I understand, it's if you know where the sun is directly. Yes?
Yeah.
Ah, okay.
Well, I determined them using a program script from the NOAA.
Okay. Thank you. Sorry. Another big question is about, you've discussed a lot particles on which scattering occurs. Still, final opinion of the reporter. Where does the scattering happen?
Well, the scattering which leads to this method working, or
yes,
that are the dipole water molecules, for example.
But not in the clouds?
No.
Just in the air. Okay, and what's the opinion of opponent?
My opinion is that from what I know, the pattern of polarization is mainly due to the scattering on atmospheric gases.
Okay, and not
then
in the
the
clouds.
degree of polarization may be reduced by the atmosphere, by other atmospheric particles like clouds and aerosols.
Okay, another question is, in the report's presentation we have seen the idea of scattering on the dipole, when light comes from it. But what will happen if the scattered light will meet another dipole?
Well, it's just a situation of a maximum, and if another dipole is there and it is scattered in another direction, it won't meet the observer.
Mm-hmm. It won't meet at all. And what's the opponent's opinion?
Well, it will meet. It will meet the observer. We can. The reason why we still see something through the clouds is that the sun, the blue polarized light, the blue light, which is already scattered, is scattered once again on the clouds.
Okay, thank you. And for the reporter, also in your presentation, I heard words about this dipole that it should be orientated correctly. What does it mean?
Well, that's for the maximum intensity of light traveling from this molecule to the observer. I can show you if you want. I can show you now. It's just a maximum. There are other orientation, and light travels from there to the observer, but it's not the maximum part of light.
Thank you.
Oh yeah.
members of Team Rivals, respected jury. My name is Stanislav Prasunin, I'm from the team of Belarus, and now I'm going to present you our review to the task we've just seen, a task named Vikings. Well, let's start from the mark to the report, what we have just seen. We have seen in the report a very good description of polarized skylight, why does it get polarized, what happens to make this polarization happen. Also, we have seen explanation for the work of polarizing materials, biofrigid materials, how does it work and how it can be applied, what's more necessary, because the whole task has a bit experimental type. You know, at all, if we're talking about the task on the IYPT, we can realize it in very different ways. For example, for this task, there were possible two ways of understanding. One way is to understand this as a totally experimental task when the reporter will try just to make a scheme for Vikings to work, and another one is the one we've just seen, the physical explanation of what is happening during effects described in the solution. Certainly, it was the reporter up to choose which type of presentation to choose, and so we have seen this physical type of the report, and certainly it's maybe better than experimental one. But still, experiments were done. We have seen really measurements for finding sun with rather big errors, but the ideas of decreasing errors were proposed. So certainly that's also a good point. And finally, we have seen a scheme for Vikings device, which could have happened Vikings to navigate also during this dull or overcast weather. However, unfortunately, not all experiment ideas were clear during presentation. Well, maybe just because there's certainly not enough time to present everything in 12 minutes, that's difficult. But another problem is that maybe there should be less time spent in the explanation of this physics. Because, for example, relay scattering, which was explained by the reporter, took, in my opinion, too much time. Its novelty of work is unfortunately very low for this presentation, because relay scattering is something pre-described a long time ago, the same as work of polarizing materials, and telling us about it half of the presentation isn't the best way to report on the IYPT. Also, even in this physics, mistakes were made, because, let me be maybe a bad guy, but I will disagree with some points in the opening and reporter's words. For example, about scattering on the dipoles, I will agree this here with the opponent that scattering must happen not on the water particles, but on the particles of gases such as nitrogen and oxygen, and on the one-atomed particles. And certainly in the clouds where light meets particles which are subsequently bigger than critical size, scattering won't happen with relay metal, or won't be applied. And so, talking about opposition, I must say that about general points of the opponent, I can agree that questions of further understanding of physics were made to understand what the reports have done. Also, opponent talked about the ways of scattering, relay scattering. Opponent added words about Snell's law for describing polarizing materials, improving our understanding of physics. Also, I will agree with the opponent about lack of photos, and that connected points on plot is rather a bad thing to do. But still, I want to mark that report was rather good. And finally, talking about discussion, well, I wasn't satisfied with it at all, because, in my opinion, too much time was spent on every point. The only good thing which was explained is question about particles in the air, and still opponent and reporter hasn't reached one point of view. At the same time, for example, question about ordinary and extraordinary beam also was given a lot of time, but in my opinion, it's rather unnecessary in this place. The same thing is arguing references. Why should we argue about someone else's work when we have great work from a reporter here? And the same thing, I already said, too much time spent on each of these points of discussion. Thanks for your attention. Thanks to the reporter, opponents.
So, to my final remark, I interpreted this task to find or to investigate if it could have been possible for the Vikings, and I investigated the method how it could have been possible. I did not focus on other ways or situations where it is not possible, and I used a method which uses maximum light, so there is light polarized in other directions, but I use only this polarization direction which has the highest degree. Furthermore, there are molecules in the air, and I only brought one example, the water molecules. Here you can see as a good example that there are dipoles, But of course, the gases of the atmosphere are also under those molecules. I just like to show one photo which was mentioned in the opposition and in the review, photo of my experiment I analyzed. So here you can see one example, and because of the beamer, I think it's not very good, but you can see the average and the median, and this is for the other angle. Probably you can see a small difference, and that's just not very interesting, but the most interesting things are those values. So I'd like to thank the opponent for this interesting discussion, and also the reviewer for his review. Thank you for your attention.